Hello students, so the question is, an ideal gas expands isothermally from volume V1 to volume V2 and is then compressed to original volume V1 adiabatically. Initially the pressure is P1 and final pressure is P3 and the total work done is W. Then we have to correct the option. First option is P3 greater than P1, W greater than 0. Third option is P3 less than P1, W less than 0. Third option is P3 greater than P1 and W less than 0. And fourth option is P3 equal to P1, W equal to 0. Now this question is based on the chapter thermodynamics. So in this question, let us draw the PV graph. On the y-axis we represent pressure, on the x-axis we represent volume. So it is written that first the gas is at initial state A. Suppose here the pressure is P1 and volume is V1 and it is expanding. That means its volume is increasing isothermally. So the graph for isothermal is in this way and it reaches to the point B. Here pressure is P2 and volume is V2. B is its final state for isothermal process. Now after reaching the state B, it will compressed back as it is given in the question. It is compressed to its original volume V1 adiabatically. So let us draw the adiabatic curve. Now we know for adiabatic process, the slope is always greater than isothermal process. That means to draw the adiabatic graph from B point, we have to draw a line of larger slope. That means towards this point, so that the volume will be same. This is C point. Here the pressure is P3 and volume is V1. Volume is V1. The process A to B is an isothermal process and the process B to C is an adiabatic process of greater slope. Now we have to determine which pressure is greater, as it is indicating here that the pressure P1 is at this point and the pressure P3 is at this point, which concludes that P3 is greater than P1. And what about the work? Now you are seeing that W2 and suppose it is W1. W1 is in positive and W2 is in negative because in W1 the gas is expanding. So work done by the system is positive and work done on the system is negative. W1 is positive and W2 is negative. And in magnitude wise, W2 is greater than W1 because the area under PV graph BC is greater than the graph AB. So that means the net work done is negative because the magnitude of negative work is greater than the positive work. So that means our correct answer will be third option. I hope that answers your question. Thank you.
The PV plot for two gases during adiabatic processes are shown in the figure. Plot 1 and 2 should be respectively option 1 helium and oxygen, option 2 O2 and helium, option 3 helium and argon, and option 4 O2 and N2. So if we look at this point, we can see that the slope, let's call this point O, slope of process 1 at point O is less than slope of process 2 at point O. Now for an adiabatic process, we know that PV to the power gamma is equal to constant. If we differentiate both sides, we get dP into V to the power gamma plus P into gamma into V to the power gamma minus 1 into dV. Since C is a constant, its differentiation is equal to 0. Upon rearranging, we get dP V to the power gamma is equal to minus gamma into P into V to the power gamma minus 1 into dV. Upon rearranging, we get dP upon dV is equal to minus gamma into P by V. Now this term dP by dV is the slope of this PV graph. Considering point O, the slope at point O, that is dP by dV at O, will be equal to minus gamma into, let's call this value P by C is equal to K. For both the processes at point O, P and V will be same, therefore we have taken P by V is equal to a constant K. Therefore we can say that dP by dV at point O is proportional to gamma. That means at point O, the slope is directly proportional to the value of gamma. Now gamma is equal to 1.67 for monoatomic gas, and it is equal to 1.4 for diatomic. This means since the gamma value for monoatomic is greater than the gamma value for diatomic, the slope at point O for diatomic gas is less than the slope at point O for monoatomic. This means here, since we have shown that slope of process 1 is less than slope of process 2, if we compare these two, we have slope of process 1 at O is less than slope of process 2 at O. We can say that the process 1 is for diatomic gas, whereas process 2 is for monatomic gas. So process 1 is diatomic and process 2 is monoatomic. Therefore, if we look at the options, option 1 says that process 1 is helium, which is monatomic, and process 2 is for oxygen, which is diatomic. That is incorrect. Option 2 says that process 1 is for diatomic, that is oxygen, and the process 2 is for helium, which is a monatomic gas. This is the correct answer. And option 3 and option 4 are also incorrect, because option 3 says that both the gases are monatomic, that is helium and argon, and option 4 says that both the gases are diatomic, which is also incorrect. So the correct answer to this question is option 2.
Let's look at the question. Starting with the same initial conditions, an ideal gas expands from volume V1 to V2 in 3 different ways. The work done by the gas is W1 if the process is purely isothermal, W2 if is purely isobaric, and W3 if purely adiabatic. Then और हमारे पास ऑप्शंस दिए हुए हैं, इनमें से हमें एक ऑप्शन चूज करना है. तो क्वेश्चन में हमसे क्या पूछ रहा है कि एक गैस है जो इनिशियली क्या थी, सेम कंडीशन पे थी, और फिर वो एक्सपेंड करना स्टार्ट करती है फ्रॉम वॉल्यूम V1 टू V2 इन 3 डिफरेंट वेज। और वो 3 डिफरेंट वेज कौन कौन से हैं? आइसोथर्मल, आइसोबारिक एंड एडियाबैटिक। ओके, और इन तीनों पाथ में जो गैस ने वर्क किया, हमें उस वर्क को क्या करना है, कंपेयर करना। तो सॉल्यूशन में मैंने सबसे पहले क्या किया है, एक पीवी कर्व ड्रॉ किया है जिसमें मैंने गैस को एक्सपेंड कराया है फ्रॉम इनिशियल कंडीशन दैट इज पॉइंट ए फ्रॉम वॉल्यूम V1 टू V2। ओके, और मैंने 3 डिफरेंट पार्ट ड्रॉ किए हैं। अब हमें सिर्फ ये चेक करना है कि कौन सा पाथ किस प्रोसेस को रिप्रेजेंट करेगा। तो अगर मैं सबसे पहले स्ट्रेट लाइन की बात करता हूँ, तो इस स्ट्रेट लाइन पाथ में प्रेशर कांस्टेंट रह रहा है, तो ये प्रोसेस डेफिनेटली हमारा क्या हो जाएगा, आइसोबारिक। और क्वेश्चन में आइसोबारिक प्रोसेस के वर्क डन को हमने क्या अज्यूम किया है, W2, तो मैंने यहाँ पे W2 लिख लिया। अब इन दोनों कर्व्स की अगर मैं बात करता हूँ, तो सिर्फ इनमें डिफरेंस क्या है, इनकी स्लोप का डिफरेंस है। तो अब हमें क्या देखना होगा कि आइसोथर्मल और एडियाबैटिक प्रोसेसेस में किसकी स्लोप ज़्यादा होती है। ठीक है, तो मैं सबसे पहले कंसीडर करता हूँ आइसोथर्मल प्रोसेस को। सो PV इज इक्वल टू कांस्टेंट। ओके, so PV is equal to constant, or now differentiating I can write P times dV plus V times dP is equal to 0. Okay, using product rule I can write this equation. So here I can write dP by dV is equal to minus P by V. Okay, now अगर मैं बात करता हूँ एडियाबैटिक प्रोसेस की, तो उसमें क्या होता है, PV रेज़ टू पावर गामा इज इक्वल टू कांस्टेंट। ओके, तो फिर से मैं डिफरेंशिएट करता हूँ, तो आई कैन राइट P इंटू गामा V रेज़ टू गामा -1, ओके, dV प्लस V रेज़ टू गामा इंटू dP इज इक्वल टू 0। ओके, यहाँ पे मैंने क्या किया है, प्रोडक्ट रूल यूज किया है। तो पहले P को कांस्टेंट रखा, V रेज़ टू गामा की डिफरेंशिएशन क्या होगी, गामा इंटू V रेज़ टू गामा -1 dV प्लस V रेज़ टू पावर गामा को कांस्टेंट रखा, P की डिफरेंशिएशन dP इक्वल टू 0। अब यहाँ से मैं V रेज़ टू पावर गामा -1 अगर कॉमन लेता हूँ, तो मेरे पास क्या आएगा, V रेज़ टू गामा -1 गामा P dV प्लस V dP इज इक्वल टू 0। ये क्या हो जाएगा, कैंसिल आउट हो जाएगा। तो यहाँ से मैं dP बाय dV क्या लिख सकता हूँ, माइनस गामा टाइम्स P बाय V। ओके, तो अगर मैं अब आइसोथर्मल और एडियाबैटिक दोनों प्रोसेसेस की स्लोप को कंपेयर करता हूँ, अगर स्लोप का मैग्नीट्यूड कंपेयर करता हूँ, तो क्लियरली मैं देख सकता हूँ कि एडियाबैटिक की जो स्लोप है वो गामा टाइम्स आइसोथर्मल की स्लोप है। तो स्लोप किस प्रोसेस की ज़्यादा होगी, एडियाबैटिक की ज़्यादा होगी। तो अब मैं क्या कर सकता हूँ, यहाँ पे ग्राफ में लिख सकता हूँ, क्योंकि इस प्रोसेस की स्लोप क्या है, कम है, तो ये मेरा क्या हो जाएगा, आइसोथर्मल, और आइसोथर्मल का वर्क डन क्या हो जाएगा, W1 से रिप्रेजेंट किया था, और नीचे वाला प्रोसेस क्या हो जाएगा, एडियाबैटिक हो जाएगा। ओके, सो अब मेरे पास तीनों प्रोसेस को मैंने डिनोट कर लिया है। अब हमें पता है कि जो हमारा वर्क डन होता है वो क्या होता है, एरिया अंडर द कर्व। तो आई कैन क्लियरली सी कि सबसे ज़्यादा एरिया किस कर्व के अंडर आ रहा है, इस कर्व के अंडर आ रहा है। सो W2 क्या होगा, सबसे ज़्यादा होगा, और उससे कम एरिया किसके अंडर आ रहा है, इस कर्व के अंडर, और सबसे कम एरिया किस कर्व के अंडर आ रहा है, इस कर्व के अंडर। तो मैं क्लियरली लिख सकता हूँ दैट W2 इज ग्रेटर देन W1 इज ग्रेटर देन W3। तो आई कैन राइट B option is correct. Okay, thank you.
Hello everyone, so our question is, two cylinders A and B fitted with piston with equal amount of an ideal diatomic gas at 300 Kelvin. The piston A is free to move while that B is held fixed. The same amount of heat is given to the gas in each cylinder. If the rise in the temperature of the gas in A is 30 Kelvin, then the rise in the temperature of the gas in B is. Okay, so we have been given two cylinders. One is having a piston which is free to move, and the another, that is the cylinder B, is having a fixed piston. Okay, now if we supply equal amount of heat in each cylinder, the rise in the temperature in the cylinder A is 30 Kelvin. Then we have to find what will be the rise of the temperature in the cylinder B. Okay, now since the heat supplied in both the cylinders are same, correct. Now cylinder A was having piston that is free to move, so it will heat at constant pressure. So the heat will be given as NCP delta T. And in the cylinder B, the piston was fixed, so it will get heated up at a constant volume, so heat will be given as NCV delta T. Correct. Now the number of moles in both the cylinder are same, so it will get cancelled out. So from here we get delta TB will be equals to Cp upon Cv times delta Ta. Okay, now Cp upon Cv is nothing but gamma times delta Ta. Now gamma for diatomic gas is 1.4 and rise in the temperature in the cylinder A is given to us as 30 Kelvin. So from here we get it as 42 Kelvin. So the rise in the temperature in the cylinder B will be 42 Kelvin. Now checking out from the options, we get our option number 4 is the correct option. Thank you.
Hey guys, the question is, when an ideal diatomic gas is heated at constant pressure, the fraction of heat energy supplied which increases the internal energy of gases. तो इसमें हमसे पूछा गया है कि डायटोमिक गैस को हम कांस्टेंट प्रेशर पे हीट करते हैं, सो वी नीड टू फाइंड द फ्रैक्शन ऑफ हीट एनर्जी सप्लाइड जो कि उसका इंटरनल एनर्जी बढ़ा देती है. सो प्रोसीड करते हैं. गैस इज डायटोमिक, मतलब इसका Cp होगा 7/2 R और Cv होगा 5/2 R. टोटल हीट एनर्जी सप्लाइड क्या होगा, mCp डेल्टा T. इंक्रीज इन इंटरनल एनर्जी होगा mCv डेल्टा T for m mass of gas. डेल्टा T है इंक्रीज इन टेम्परेचर, इंक्रीज और डिक्रीज इन टेम्परेचर. सो हमें निकालना है डेल U और Q का रेशियो, इंक्रीज इन इंटरनल एनर्जी और टोटल हीट सप्लाइड का. सो दैट विल बी mCp del T, so mCv del T और mCp del T के इक्वल दिस विल बी Cv by Cp. Cv और Cp की वैल्यूज रखते हैं 5/2 R और 7/2 R, ये होंगे 5/7. सो हमारा आंसर होगा del U by Q equals to 5/7.
Well, hello students, now we're going to see this question. The question says that an ideal monoatomic gas is taken a round cycle ABCDA as shown in the PV diagram. So this is basically the path followed by the thing, the work done. Okay, basically the work done during the cycle is, so we need to find the work done. So work done is basically what? In a PV diagram, work done in PV diagram, PV graph, let's suppose graph is area under PV curve. Okay, this is basically the area under PV curve. So what will get the basically the over here, what we can say over here is that the work done is basically what? The work done is this area. This square you can see over here, this area will be the work done of the thing. Okay, you must remember that the work done is basically the area enclosed by the cyclic thing in the PV graph only. Okay, only in the PV graph. So this is basically the work done area of this. So what will be the area basically of this? Let's write down now. Area will be equal to BA multiplied by BC. Okay, let's suppose not BC, let's suppose AD. Okay, because BC is equal to AD. So what we have basically, BA will be equal to, if we see over here, this is also point V, this is also V, means the x coordinate is basically, means y coordinate is basically same over here, but over here you can understand that this is V, so basically the x coordinate is same over here. Okay, where it is written afterwards, but it is basically representing the x coordinate. Okay, and P, you can see P changes from P to 2P, means the side has a length of basically 2P, basically not P, 2P minus P, which will be equal to P. Okay, so I'm writing over here, it will be 2P minus P, which will be equal to P. Okay, and basically this side you can see P is constant, but V is changing to 2V, so this side will be 2V minus V, which will be equal to V. So what we'll get, basically we'll get the area will be equal to P into V, okay, which will be equal to PV. Okay, so our answer is basically PV. So our answer is basically work done is equal to PV. Got it? Thank you.
Hello everyone, let us try to solve the given problem. So in the given problem, it says 1 mole of a monoatomic ideal gas is taken along 2 cyclic processes as shown in the PV diagram. The processes involved are isobaric, isothermal or adiabatic. Then we have to match that which of these processes GE, the work done with their respective process, right? So we have to find the magnitude of work done in the respective processes. So let's start with the process FG. So let's start with the process FG, right? So FG, right? FG is an isothermal process. Why isothermal? Because we can see that the slope of isothermal is less than the slope of the adiabatic process. So this is an isothermal process where the temperature is constant. And what is the formula for isothermal work done in an isothermal process? So WFG will be simply equals to nRT ln. Now let's put the values. So we do not know the temperature here, so in place of RT we can substitute the pressure and volume that we know. N is simply 1, and in place of RT we can write P naught V naught, since the temperature is constant, so simply we can write this is 32 times P naught into V naught. Now ln is 32 P naught divided by P naught, right? So this P naught and P naught will cancel. Ln 32 we can write, so we can take 2 here, 5 here, so this will be 5 into 32 P naught V naught ln 2, right? So this will be 2 to the power 5, so we have taken 5 here, so this will be simply equals to 160 P naught V naught ln 2. So FG matches with option P. So the work done in the process FG is 160 P naught V naught ln 2, right? So let's try to find out work done in the process G to E. So work done in the process G to E is simply, this is an isobaric process. So you can see that GE is an isobaric process where the pressure is constant and the volume is decreasing, we can see. So we can simply find out P dV. Now to find dV we need to know the volume here, so we can simply apply isothermal relation between F and G to find the volume here. So you can see that this is 32 times P naught V naught, this is equals to, so here we have to find volume. So the pressure is P naught and the volume, let us take this as V. So this gets cancelled, so what we get volume at G is simply 32 times V naught. So now we know the change in volume also. The pressure is P naught simply, and the change in volume will be simply, this will be final volume is V naught and the initial volume is, so you can see here that the work done will be simply minus 31 P naught V naught. This will be the work done in the process GE. Right, now we have to simply take the magnitude. So this will be WGE. We can take this as simply, if we take the magnitude, so this will be simply 31 P naught V naught. Now we have found out the work done in the process GE, and you see the work done in the process GE is simply 31 P naught. So this matches with H. Now let's try to find out the work done in the process F to H. Now let's try to find out WFH. So WFH, we can see that this is an adiabatic process, right? So for an adiabatic process, what we first need to know, if we apply the formula for work done, so this will be simply equals to P1 V1 minus P2 V2 divided by gamma minus 1. Now you can see that we know the P1 and P2, but we don't know V1, but we know V1, but we don't know V2. So first we need to find out V2, that is what is the volume here. So let us try to apply the adiabatic relation between point F and H to find out the relationship. So how do we apply? So we know that P1 V1 to the power gamma is equals to P2 V2 to the power gamma. So from here P1 is 32 times P naught. This is 32 times P naught, and V1 we know that this is V naught to the power gamma, and gamma is simply 5 by 3 since this is a 1 mole of. Now P2 is simply P naught. P2 is equals to P naught, and we have to find V2 to the power 5 by 3. So when we solve from here, what we get? We get V2 is equals to 8 V naught. Now we know P1 V1, we know gamma, we know P2 V2. So if we find out the work done during the process FH, so when we substitute the values, so what we are going to get? We are going to get. So you can see I have substituted the values, and WFH I have found out to be 36 P naught V naughts. When we solve, when we put the values and solve, then we find out 36 P naught V naught. So let's see that in the process FH. So this is simply Q. And now let's find out for the process G and H. So we have to find for the process GH. So this is the last process. Let's find for GH. So GH is again an isobaric process. So this is an isobaric process, right? So it is an isobaric process. So we can simply find out WGH. This will be equals to P times the volume is decreasing here again. So volume is decreasing. See, we can see in the process GH volume is simply decreasing. So at G we have the volume 32 V naught, and at H we have 8 V naught, and the pressure here is simply P naught. So from here what we are going to get? We are going to get 32 minus 8 is simply 24 times V naught. So we are going to get 24 P naught V naught. So this is the final answer that we had to get. So we have found out that the work done in the process G to H is 24. This is R. So this is the correct option. I hope you understood the explanation. Thank you. Hello everyone, let us try to solve the given problem. So the given problem is match the column type, and it says 1 mole of a monoatomic ideal gas is taken through a cycle A, B, C, D, A as shown in the PV diagram. Now column 2 gives the characteristics involved in the cycle. Now we have to match the processes with their characteristics. So here in the column 1 we have some processes, and here we have characteristics. So let's try to match out one by one. So let's see first process A and B. Now if you see process AB, right, so this is a constant pressure process. So pressure is constant, and we can see that the volume is decreasing. So when the volume is decreasing, pressure is constant, then the temperature has to decrease, because volume is directly proportional to temperature, which simply means that the internal energy of this ideal gas will simply decrease, right? Now let's try to find out. First thing, we have found out that the process A and B internal energy will decrease. So P will match with this first thing that we have found out. Now let's see what about the work and what about the heat. Since the volume is decreasing, so we can see that W is equals to P dV. Since this is a constant pressure process, so since the volume is decreasing, so W will be simply less than 0. So which simply means that the work is done on the gas. So this is PT. And if we apply first law of thermodynamics, so see what we are going to get. We are going to get Q is equals to delta U plus W. Now W is less than 0 and internal energy is also decreasing, which means the change will be negative. So which simply means that the Q is less than 0, which means that heat is lost from the system. So this has T, P and R. So in the process 1, so we can write here, this is P, R and T. So this will be the correct option for A. Now let's check for the process BC. Process B to C. Now let's see which are the correct options. So for the process BC, you can see that this is a constant volume process. Volume is equals to constant, so isochoric process. And the pressure is decreasing, right? So when the pressure decreases, temperature has to decrease. And when the temperature is decreasing, internal energy of the ideal gas has to decrease. So which simply means that the change in internal energy is again negative. So internal energy decreases. So the process BC, we can also write this P. Now, when delta U is less than 0, we simply see here that W will be 0 because the volume is constant. So when internal energy decreases, heat is equals to W plus delta U. So from here you can see that W is 0, delta U is negative. So Q has to be negative, and when Q is negative, when heat is lost from the system. So Q is less than 0, so heat is lost. So this is P and R. Now let's check for the for C and D. Now C and D. Now in C and D, again the pressure is constant. So pressure is constant, pressure is equals to constant, and the volume is increasing, right? So when the volume is increasing, temperature has to increase. And when the temperature increases, the temperature of an ideal gas increases, its internal energy has to increase. So that means that change in the internal energy will be greater than 0, or it will be positive. Internal energy is increasing. So process CD, internal energy is increasing. Now we can also see that W will be greater than 0. W will be greater than 0. That is, work is done by the gas. So here we don't have any options for that. And if we apply first law of thermodynamics, so what we are going to get, we are going to get delta U plus W. This will be greater than 0 because both are positive. So which means that heat is gained by the system. So this will be Q and S. Now let's check for the last process, which is D to A. Now first we need to find out that process DA which sort of process. So for that we need to find out temperature on these points. So let us try to find out temperature at A. So that will be simply, since this is a 1 mole gas, so the temperature at A, we can apply the ideal gas equation. So that will be PV divided by RT. We need not to put the values. So simply we can see that at A, the pressure is 3P and the volume is 3V. So this will be 9 PV divided by RT. And if we found out TD, we are going to get the same result. So that will be again PV, pressure at D, divided by RT. So you are going to get the same result. So this will be 9 PV divided by RT. So you can see that the temperature at these 2 points is constant, which simply means that this is an isothermal process. So process DA is an isothermal process. DA is an isothermal process, which simply means that the temperature is constant. So when the temperature is constant, for an ideal gas, change in the internal energy is 0. So internal energy will not change. Now let's check for the other option. So let's try to find out the work done in an isothermal process, right? Work done in the isothermal process is simply nRT log or natural log V2 divided by V1. You can see that this is an isothermal compression, so the volume is decreasing, so which simply means that W will be less than 0. W will be less than 0, and when W is less than 0, change in internal energy is negative. We can apply the first law, so which will give us Q is equals to delta U plus W. Now this is 0, so if Q is negative, if W is negative, so Q has to be less than 0. So we can see here that the work is done on the gas. So this is true. Internal energy of the gas does not change here, either increases or decreases, and the heat is lost from the system. So this will be T and R. So I hope you understood the explanation. Thank you.
Hello everyone. So the question is, an ideal monoatomic gas is confined in a horizontal cylinder by a spring loaded piston as shown in the figure. Initially the gas is at temperature T1, pressure P1 and volume V1, and the spring is in its relaxed state. The gas is then heated very slowly to the temperature T2, pressure P2 and volume V2. During this process, the piston moves out by a distance x. Ignoring the friction between the piston and the cylinder, the correct statement is or are. There are 4 statements given in the question and we have to tell that which statement is correct and which is not. Okay, so you can see this is my horizontal container or a cylinder and this is my piston. So at initially the pressure is the pressure is P1, volume is V1 and temperature is T1. Now we heat it slowly and after that my pressure is changed to P2, volume is V2 and temperature is T2, and there is a displacement in piston which is by x. Okay, now from ideal gas equation I know that from ideal gas equation I can say that P1 V1 upon T1 equals to P2 V2 upon T2, because my ideal gas is PV equals to nRT. N is constant, R is constant, so I can write my ideal gas equation for initial condition and for final condition. So it is P1 V1 upon T1 equals to P2 V2 upon T2. So from here I can find out my value of P2, which is coming out to be 3 by 2 P1, because I am going to solve the statement 1, and statement 1 they are saying that if V2 is equal to 2V1, so putting the value of V2 as 2V1, T2 as 3T, and then the spring energy stored in the spring is 1 by 4 P1 V1. So my P2 is coming out to be 3 by 2 P1. Now the change in internal energy, we all know that change in internal energy delta U is given by F by nRT. Okay, so I can also write this as F is the degree of freedom, and in the question they are saying that my gas is monatomic, so value of F is 3 for monatomic gas. Okay, so 3 by 2 and R delta T is change in temperature, so it is T2 minus T1, and I can also write from ideal gas equation, my ideal gas equation is PV equals to nRT. So in the place of nRT2 minus T1, I can write 3 by 2 P2V2 minus P1V1. Simple. Now I am going to put in the value of P2, which I calculated. So my delta U equals to 3 by 2 value of P2, which is 3 by 2 P1 into value of V2, which is given in the statement 2V1 minus P1 V1. After solving this, my internal energy is coming out to be 3 P1 V1. Okay, this is my internal energy. Okay, and the energy stored in spring, which is given by the energy stored in spring E. Suppose the energy stored in spring is E and it is given by half kx square, where k is the constant and x is displacement. Now we have to derive this energy in the form of P and B, in the form of pressure and volume. So I know at initially my temperature is P1, but when spring is, now my piston moves via the distance x, that means in piston the force because of this piston is kx. Okay, so the pressure because of this piston is kx by a, because the area of piston, suppose the area of piston is a, this is my a. So pressure because of this spring on the piston is given by kx upon a. So my initial pressure is P1 and my final pressure, that is P2, which is equal to P1 plus pressure because of spring, that is Kx by A. This is my final pressure. Similarly, my V1 equals to V is given by the area into displacement. So my V1 is Ax. Similarly, my V2 is equal to the V1 plus Ax. Okay, from this equation P2 equals to P1 plus Kx by A. From this equation I can find the value of, put the value of P2 in this equation. I will get, so P2 equals to P1 plus Kx upon A. Now putting the value of P2, which we already calculated, that is 3 by 2 P1. P1 equals to P1 plus Kx by A. P1 to P1 cut. So I will get my value of Kx, that is equals to P1A upon 2. Okay. Similarly, this we find out from this equation. Okay. Now from this equation, which is equal to B2 equals to B1 plus Ax. Okay. My final volume is V1 plus Ax. The value of V2 is given in the question, which is 2V1. So I can find my value of X equals to V1 upon A. This is the value of X. Now I have the value of Kx as well as the value of X. So I am going to put the value of Kx and X in the formula of energy stored in spring, because I want this energy in the form of pressure and volume. So I change my K and X in the aspects of pressure and volume. Half value of Kx is P1A upon 2, and because this is basically Kx dot X. Okay, so the value of Kx is P1A by 2 and the value of X is B1 upon A. So my energy stored in spring is coming out to be P1 V1 upon 4. Now we are going to check statement first and statements second. Okay, the statement first is, because in first and second statement they are giving the final volume and the temperature same, so I solve them together. Okay, so the internal energy stored in the spring is P1 V1 by 4, correct? We just calculated this, and the change in internal energy is 3 P1 V1. We solved this earlier. Okay, and the value is correct. So these two statements are correct. Now in last two statements they are saying my B2 is 3V1 and T2 is 4T1. Then the work done by the gas is 7 by 3 P1 and the heat supplied to the gas is 17 by 6. In last two statements, they are changing the value of final volume and the final temperature. So we know that work done is basically the integration of PdV, where P is the pressure and dV is the change in volume. Now I can also write this as equals to, I can write in place of P, P1 plus Kx upon A. This is my final pressure after spring is working on piston, dV. Now I can write this also as PdV, okay, plus integration of Kx upon A dV. Simple. Now I know that my volume is equals to area into X, so I can write my dV equals to A dx. Okay, so I'm going to put this value as equals to P1 dV from V1 to V2 plus Kx upon A, and in place of dV I am going to write A dx. A to A cut. Now this is the integration with respect to X, so putting the limit in X 0 to X. Now integrate these terms. I will get finally W equals to P1 is constant and the integration of dv is v, putting the limits v2 minus v1, final limit minus initial limit, plus kx square by 2. Okay, now from ideal gas equation, I know from ideal gas equation I can write for initial and final condition P1 V1 upon T1 equals to P2 V2 upon T2. The value of V2 and T2 is given in the statement that my V2 is equal to the 3V1 and T2 is 4T1. In the equation they are giving that my V2 is equals to 3V1 and T2 is equals to 4T1. So putting these value, I will find out my pressure, final pressure, that coming out to be 4 by 3 P1. Okay, similarly by using the equation V2 equals to V1 plus AX, my final volume is equal to the initial volume plus AX, which is the volume because of the spring. So I can find out the value of X, which is coming out to be 2 V1 upon A, because I am going to putting the value of V2 which is given in the question 3V1. So I got my value of X, that is 2V1 upon A. Now I am going to put the value of X and value of P2 in this equation of work done. So after putting the value of P2 and X in this formula, I will get P equals to W equals to 2 P1 V1, because my V2 is 3 P1 minus V1 equals to 2, plus kx square by 2. So I am putting the values. The values are, when I am putting the values, half the values of kx, which is P1 by 3, which I already calculated before, into the value of x, which is 2V1 upon A. How I calculate the value of kx before? Similarly, I am going to, because I have my value of P2, so I can write here P2 equals to P plus kx upon A. Putting the value of P2, I can find out the value of kx, which is coming out to be P1A upon 3, what I put in my work done. Okay, so this is the easy calculation. I think you all can do this. W equals to, finally my work done is coming out to be plus P1 V1 upon 3, and my work done is 7 by 3 P1 V1. Okay, so let's check the statement. What the statement states, that the work done by the gas is 7 by 3 P1 V1, correct? And the last statement is saying that the heat supply to the gas is 17 by 6. Now we have to find out the heat supply to the gas, and from thermodynamics first law I know that my heat is given by the sum of work done plus internal energy. Now I already calculated my work done as well as my change in internal energy. Putting the values of both, I got it is 7 by 3 P1 V1, and my internal energy is 3 by 2 P2 V2 minus P1 V1. So the Q is coming out to be 7 by 3 P1 V1 plus 3 by 2, putting the value of P2, which I already calculated, this 4 by 3 P1. Okay, 4 by 3 P1 into V2 is given in the question 3 V1 minus P1 V1. After simplifying this, finally my energy is coming out to be, or heat supply to the gas is 41 by 6 P1 V1. Okay, but in the statement they are saying that my heat supply to the gas is 17 by 6 P1 V1, which is not correct.
हेलो गाइस, इस वीडियो में क्वेश्चन देखेंगे जो कि बेस्ड है थर्मोडायनेमिकल प्रोसेसेस पे। क्वेश्चन में क्या बोला है, 1 मोल ऑफ आइडियल गैस इन इनिशियल स्टेट ए अंडरगो ए साइक्लिक प्रोसेस ABCDA और शोन इन फिगर, इट्स प्रेशर एट A इज P0। यहाँ पे जो प्रेशर है वो P0 है। चूज द करेक्ट ऑप्शंस फ्रॉम द फॉलोइंग, ठीक है। तो हमें ये एक एक ऑप्शन बताना है कि इनमें से कौन सा करेक्ट है कौन सा इनकरेक्ट है। और यहाँ पे हमें जो प्रेशर दे रखा है वो पी नॉट दे रखा है, ठीक है। तो सबसे पहले ऑप्शन ए की बात करते हैं। इंटरनल एनर्जी एट ए एंड बी आर द सेम। तो देख सकते हैं क्योंकि ए से बी तक क्या है, प्रेशर आइसोथर्मल है, टेम्परेचर जो है वो कांस्टेंट रह रहा है ना, टी नॉट ही रह रहा है। तो ए से जो बी है प्रोसेस, वो कौन सी प्रोसेस है, आइसोथर्मल प्रोसेस, ठीक है। अब आइसोथर्मल प्रोसेस में क्या होता है, जो चेंज इन इंटरनल एनर्जी होती है, चेंज इन इंटरनल एनर्जी क्या होती है, एन सी वी डेल्टा टी, ठीक है। तो देखो एन तो क्या है, नंबर ऑफ मोल्स कांस्टेंट है किसी गैस के लिए, अगर मान लो किसी कंटेनर में है ना। सी वी कांस्टेंट है, समझ गए, क्योंकि मान लो मोनोएटॉमिक गैस है तो मोनोएटॉमिक या डायटॉमिक कोई सी भी गैस है तो वो फिक्स रहेगा। बचा डेल्टा टी। अब क्योंकि डेल्टा टी चेंज नहीं हो रहा इस ए से बी में, डेल्टा टी चेंज नहीं हो रहा, तो क्या डेल्टा यू चेंज होगा, यानी इंटरनल एनर्जी चेंज होगी, नहीं, ठीक है। तो क्योंकि यहाँ टेम्परेचर चेंज नहीं हो रहा तो डेल्टा यू भी यानी इंटरनल एनर्जी चेंज नहीं होगी, मतलब इंटरनल एनर्जी सेम रहेगी। तो ये वाला ऑप्शन जो है हमारा करेक्ट है। आगे आते हैं किस पे, ऑप्शन बी पे। वर्क डन बाय द गैस इन ए प्रोसेस ए बी इज पी वी नॉट इंटू एल एन की एल एन फोर, ठीक है। तो देखो जो वर्क डन इन आइसोथर्मल प्रोसेस का फॉर्मूला होता है, वर्क डन इन आइसोथर्मल प्रोसेस वो क्या होता है, एन आर टी, ठीक है। टी क्या होता है, वो जो भी टेम्परेचर टी नॉट कॉन्स्टेंट है वो होता है यहाँ। तो यहाँ लिख देते हैं एन आर टी नॉट इंटू एल एन वी टू अपॉन वी वन। वी टू क्या होता है, फाइनल वॉल्यूम, वी वन क्या होता है, इनिशियल वॉल्यूम, ठीक है। तो यहाँ से अगर वर्क डन निकालें तो ये क्या हो जाएगा, एन आर टी नॉट इंटू एल एन, और वी टू क्या है, देखो वी टू है फोर वी नॉट और वी वन है वी नॉट। तो यहाँ से हम लिख सकते हैं फोर वी नॉट अपॉन वी नॉट। तो वी नॉट से वी नॉट कैंसिल हो जाएगा और हमारे पास वर्क डन फ्रॉम ए टू बी लिख लेते हैं यहाँ। फ्रॉम ए टू बी क्या आ जाएगा, एन आर टी नॉट इंटू एल एन फोर, ठीक है। अब ये वाला ऑप्शन इससे तो मैच नहीं हो रहा क्योंकि यहाँ पी वी नॉट है, पर क्योंकि हमें पता है आइडियल गैस इक्वेशन क्या होती है, पी वी इज इक्वल टू एन आर टी होती है ना। तो यहाँ हम एन आर टी नॉट अगर लिखें इसे, एन आर टी नॉट, सॉरी यहाँ आर नॉट नहीं टी नॉट आएगा, तो इसे हम पी नॉट वी नॉट लिख सकते हैं। अब कुछ बच्चे सोच रहे होंगे कि यहाँ तो क्या है, यहाँ प्रेशर और वॉल्यूम तो कांस्टेंट नहीं है। तो देखो ये हमें पता होना चाहिए, अगर टेम्परेचर कांस्टेंट है तो पी वी नॉट तो वैसे ही कांस्टेंट होगा, है ना, क्योंकि एन आर मतलब क्या है, एन आर नॉट है यहाँ, मतलब आर है, सॉरी आर। तो एन आर तो कांस्टेंट है, अब टेम्परेचर कांस्टेंट है तो पी वी तो कांस्टेंट ही होगा ना, यानी पी नॉट वी नॉट होगा, समझे। तो यहाँ हम एन आर टी नॉट को हम क्या रिप्लेस कर सकते हैं, पी नॉट वी नॉट इंटू एल एन फोर। तो ये हमारे पास आ गया वर्क डन फ्रॉम ए टू बी। तो ये ऑप्शन जो है हमारा सेकंड ऑप्शन, ये भी बिल्कुल करेक्ट है, समझ गए। देखो यहाँ पे प्रेशर हमें दे रखा है पी नॉट, अब समझो कैसे कांस्टेंट होगा, क्योंकि यहाँ अगर यहाँ से यहाँ जा रहे हैं तो वॉल्यूम फोर टाइम्स हो रहा है ना, मतलब प्रेशर पी नॉट बाय फोर हो जाएगा, ठीक है। तो इन दोनों का प्रोडक्ट जो है मतलब वॉल्यूम और प्रेशर का, तो ये फोर से फोर कैंसिल हो जाएगा, पी नॉट वी नॉट ही रहेगा, समझ गए। तो प्रेशर एट बी क्या हो जाएगा, पी नॉट बाय फोर, ये ध्यान रखना। और हमारा वर्क डन पी नॉट वी नॉट एल एन फोर आ जाएगा। अब आते हैं सी पे। तो देखो हमें क्या बोला है, प्रेशर एट सी इज इक्वल टू पी नॉट बाय फोर, ठीक है। मतलब सी पे प्रेशर पी नॉट बाय फोर है। अगर ध्यान से देखें तो ये क्या है, वॉल्यूम, और ये है टेम्परेचर, है ना। तो हम इस ग्राफ को देख के ये कह सकते हैं, मतलब प्रोसेस सी और बी के लिए, बी से सी के लिए सिर्फ, कि वॉल्यूम इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर, है ना। क्योंकि जैसे जैसे वॉल्यूम डिक्रीज कर रहा है वैसे वैसे टेम्परेचर भी डिक्रीज कर रहा है, देख सकते हो वॉल्यूम डिक्रीज कर रहा है तो टेम्परेचर भी लीनियरली ही डिक्रीज कर रहा है ना। तो ये हम ये चीज़ किसके लिए कह सकते हैं, बी से सी प्रोसेस के लिए क्या कह सकते हैं, वॉल्यूम इज डायरेक्टली प्रोपोर्शनल टू टेम्परेचर। और ये कब होता है, जब प्रेशर जो रहे वो पूरी प्रोसेस में कांस्टेंट रहे, है ना, क्योंकि हमारी आइडियल गैस इक्वेशन क्या होती है, PV इज इक्वल टू NRT होती है ना। तो अगर प्रेशर कांस्टेंट है और NR तो कांस्टेंट है ही, तो वॉल्यूम जो है डायरेक्टली प्रोपोर्शनल आ जाएगा टेम्परेचर के, है ना। तो हम कह सकते हैं कि यहाँ इस दौरान B से C प्रोसेस में प्रेशर जो है वो कांस्टेंट है, समझ गए ना, क्योंकि वॉल्यूम के साथ साथ टेम्परेचर लीनियरली डिक्रीज कर रहा है, समझे। अगर C से B होता तो हम ये बोल सकते थे कि लीनियरली इंक्रीज कर रहा है, समझ गए। तो V डायरेक्टली प्रोपोर्शनल टू टेम्परेचर, दैट मीन्स प्रोसेस इज आइसोबारिक, ठीक है, प्रेशर यहाँ कांस्टेंट है। तो क्योंकि यहाँ बी नॉट पे प्रेशर हमने निकाला P0/4, कैसे निकाला था, क्योंकि यहाँ इन दोनों का मल्टीप्लिकेशन P0 V0 आना चाहिए था, है ना। तो वो तभी आता जब यहाँ प्रेशर P0/4 होता, क्योंकि 4 से 4 कैंसिल हो जाता और P0 V0 ही यहाँ मतलब मल्टीप्लिकेशन आता, समझ गए। तो यहाँ प्रेशर P0/4 है और इस पूरे प्रोसेस के दौरान प्रेशर क्या है, कांस्टेंट। मतलब यहाँ जो प्रेशर है वो कितना है, P0/4 एट C। तो ये जो ऑप्शन है, ऑप्शन थर्ड भी हमारा करेक्ट है। अब आते हैं फोर्थ ऑप्शन पे, टेम्परेचर एट C इज T0/4। तो ये चेक कर लेते हैं। देखो प्रेशर हमें पता है, यहाँ वॉल्यूम पता है, ठीक है, C पे। और यहाँ अगर प्रोसेस BC की बात करें तो प्रेशर कांस्टेंट है ना, यानी आइसोबारिक प्रोसेस है, कौन सी, B से C तक। यहाँ प्रोसेस लिख देते हैं, तो आइसोबारिक प्रोसेस है B से C। इसका मतलब क्या है, V इज डायरेक्टली प्रोपोर्शनल टू T, या फिर हम बोल सकते हैं वॉल्यूम अपॉन टेम्परेचर मस्ट बी इक्वल, मतलब मस्ट बी कांस्टेंट, ये हम बोल सकते हैं, है ना। तो देखो यहाँ से हम ये लिख सकते हैं, वॉल्यूम एट A अपॉन टेम्परेचर एट A इज इक्वल टू वॉल्यूम एट B। ए नहीं, हमारा ये कौन सा है, BC प्रोसेस है, तो BC लिख देते हैं, B एंड यहाँ भी B और यहाँ C और यहाँ भी टेम्परेचर एट C, ठीक है। तो ये हम लिख सकते हैं। अब देखो वॉल्यूम एट B क्या है, वॉल्यूम एट B जो है हमारा ये है 4V0, ठीक है, तो पुट कर देते हैं 4V0। टेम्परेचर एट B क्या है, T0 ही है, क्योंकि टेम्परेचर तो यहाँ पूरा ये कांस्टेंट ही है ना, T0 है। हमें क्या निकालना है, टेम्परेचर एट C। वॉल्यूम एट C क्या है, देखो C पे वॉल्यूम जो है वो V0 है, तो यहाँ हम लिख लेते हैं V0। तो ये V0 से V0 कैंसिल हो जाएगा, TC अगर इधर भेज दें तो TC क्या आ जाएगा हमारा, T0/4, ठीक है। या फिर ऐसे भी सोच सकते हो कि दोनों को रेसिप्रोकल कर दिया। तो टेम्परेचर एट C हमारा क्या है, T0/4, मतलब फोर्थ ऑप्शन भी करेक्ट है, ठीक है। तो हमारे यहाँ चारों जो ऑप्शन है वो करेक्ट है। थैंक यू गाइस फॉर वॉचिंग दिस वीडियो।
Hello, we are given with a question and the question says the figure shows PV plot of an ideal gas taken through an cycle ABCDA. The part ABC is a semicircle and CDA is a half of an ellipse. So ABC is a semicircle and this is somewhat an ellipse, right? So what? The process during the path A and B is isothermal. So from A to B, since for isothermal that is T equals to constant, right? So PV should be constant too from ideal gas equation, that is PV equal to nRT, right? So this should be a straight line instead of being a curve. So this is wrong, right? Second, heat flows out of the gas during path BCDA, this path, right? So when in process BCD till D, right, this path, volume is decreasing as we can see, right? So I am right here. Volume is decreasing, right? So if volume decreases, that means temperature decreases, right? So delta U would be negative, right? Why? Because delta U has a formula that is NCV delta T, right? Since it is dependent on temperature change, since the temperature is decreasing, delta T would be negative. So delta U would also be negative, right? So this is heat flows out of the gas. So in physics, if this is negative, right? Delta Q would also be negative. right? So if delta Q is negative, that means the heat flow is out of the gas. So this is correct. Now work done during path ABC is 0. So during ABC, the work done is 0, right? So how can we say that? Work done in this process is not 0, right? As we can see, there in PV graph, right? There is some area under this curve, right? So that means that work done is not equal to 0, right? So this is not correct, surely not correct, as by seeing the graph. Positive work is done by the gas in cycle ABCDA, right? Since the cycle is clockwise, right? And the area is being covered, right? Since cycle is clockwise, right? So what we can say is that the work done would be positive, right? So this are the answers. So our answers is B and D. Thank you.
During the melting of a slab of ice at 273 Kelvin at atmospheric pressure, option 1 says work done by atmosphere on the system is positive. Option 2 says work done by atmosphere on system is negative. Option 3 says change in internal energy is equal to ml, and option 4 says change in internal energy is greater than ml. So looking at the first two options, option 1 says that work done by atmosphere on the system is positive, whereas option 2 says that it is negative. The correct one out of these two is option 1, because when ice is melting, volume decreases. Of ice. So volume of ice decreases. If we have a container and it is filled up to here with ice and the atmospheric pressure P80m is acting on it, upon melting there is change in volume, so this becomes the new volume of the melted substance, and this is the new volume delta V that is occupied by the atmospheric pressure. So there is change in volume because of the atmospheric pressure, and because work is done by the atmosphere, therefore work done is positive. Also, if we consider the ice as our system, then W ice is negative because its volume is decreasing. The first two options asked about work done by atmosphere, and this will be positive. W ice will be negative because work is done on the ice by the atmosphere. Therefore, we know that delta Q is equal to delta U plus W ice. If we take ice as our system, then delta U will be equal to delta Q minus W ice, and delta Q will be positive because heat is added to the ice, and W ice has a negative value. So negative negative becomes positive, therefore delta U will be equal to overall positive value, and the heat added we know is equal to M into L. So we can write delta U as ml plus the work done on the ice. The work done on the ice will be equal to work done by the atmosphere. And since W80m is a positive value, we can say that delta U is greater than delta Q and we know that delta Q is equal to ml. Therefore, if you look at the options 3 and 4, option 4 will be correct because change in internal energy is greater than ml.
Hello students, question చదువుదాం. For an ideal gas అని చెప్పేసి స్టేట్మెంట్స్ ఇచ్చారు. So let us go statement to statement. A firstly, the change in internal energy in a constant pressure process from the temperature T1 to T2 is equal to NCV into T2 minus T1, where CV is the molar heat capacity at constant volume, N is the number of moles of the gas అన్నాడు. So ఇక్కడ we are talking about change in internal energy at constant pressure process. So constant pressure process లో మనకి whatever the heat we supply, that will be used for partly increasing internal energy, partly to do work. అయితే delta U value మాత్రం it will be equal to NCV delta T. So delta T అంటే change in temperature. సో చేంజ్ ఇన్ టెంపరేచర్ పాజిటివ్ ఉంటే మనకి డెల్టా యూ పాజిటివ్, లేకపోతే నెగిటివ్. ఓకే, సో చేంజ్ ఇన్ టెంపరేచర్ అంటే ఫైనల్ టెంపరేచర్ మైనస్ ఇనిషియల్ టెంపరేచర్. సో దెర్ ఫోర్ ఎస్, ద చేంజ్ ఇన్ ఇంటర్నల్ ఎనర్జీ ఈజ్ ఈక్వల్ టు ఎన్సీవీ ఇంటూ T2 మైనస్ T1. సో ఇక్కడ ఎన్ అంటే నెంబర్ ఆఫ్ మోల్స్, సివి అంటే మోలార్ స్పెసిఫిక్ హీట్ అట్ కాన్స్టెంట్ వాల్యూమ్. ఓకే, సో ఎందుకంటే కాన్స్టెంట్ వాల్యూమ్ దగ్గర వర్క్ డన్ జీరో కాబట్టి వాట్ ఎవర్ ద హీట్ వి సప్లై దట్ విల్ బి యూస్డ్ ఫర్ డూయింగ్ ద వర్క్ అనమాట. That will be used for increasing the internal energy. So అందుకే delta U value NCV into T2 minus T1. So A is correct. Okay. So ఆ తర్వాత B విషయానికి వస్తే the change in internal energy of the gas and work done by the gas are equal in magnitude in an adiabatic process అని చెప్పేసి అన్నాడు. So the change in internal energy of gas and work done అనేవి magnitude wise they are equal adiabatic process లో అని చెప్పేసి అన్నాడు. సో అడియాబాటిక్ ప్రాసెస్ విషయానికి వచ్చినట్లయితే అడియాబాటిక్ ప్రాసెస్ అంటే కంప్లీట్లీ ఐసోలేటెడ్ ప్రాసెస్ వేర్ దెర్ ఇస్ నో నెట్ హీట్ ఇన్ ద సిస్టమ్. సో డెల్టా క్యూ హీట్ గివెన్ బై ద సిస్టమ్ ఆర్ హీట్ టేకెన్ బై ద సిస్టమ్ రెండు జీరోనే. ఓకే, సో అలాంటి ప్రాసెస్లో ద ఇంటర్నల్ ఎనర్జీ చేంజ్ విల్ బి ఈక్వల్ టు మైనస్ ఆఫ్ వర్క్ డన్. మ్యాగ్నిట్యూడ్ వైజ్ చూసినట్లయితే సో ద మ్యాగ్నిట్యూడ్ ఆఫ్ ఇంటర్నల్ ఎనర్జీ చేంజ్ ఈజ్ ఈక్వల్ టు మ్యాగ్నిట్యూడ్ ఆఫ్ వర్క్ డన్. అదే మనకి ఇక్కడ ఇచ్చింది చేంజ్ ఇన్ ఇంటర్నల్ ఎనర్జీ ఆఫ్ గ్యాస్ అండ్ వర్క్ డన్ ఆర్ ఈక్వల్ ఇన్ మ్యాగ్నిట్యూడ్. సో బి ఇస్ కరెక్ట్. ఓకే, సో ఆ తర్వాత మనం సి విషయానికి వచ్చినట్లయితే ద ఇంటర్నల్ ఎనర్జీ డస్ నాట్ చేంజ్ ఇన్ అన్ ఐసోథర్మల్ ప్రాసెస్ అని చెప్పేసి సి అంటున్నాడు. సో ఇక్కడ వీఆర్ టాకింగ్ అబౌట్ ఐసోథర్మల్ ప్రాసెస్. యాజ్ ద నేమ్ ఇండికేట్స్ ఐసోథర్మల్ ఇట్ మీన్స్ టెంపరేచర్ ఈజ్ కాన్స్టెంట్ అని. టెంపరేచర్ రిమైన్స్ కాన్స్టెంట్ త్రూ అవుట్ ద ప్రాసెస్. సో వెన్ టెంపరేచర్ ఈజ్ కాన్స్టెంట్ delta T, the change in temperature is 0. So change in temperature 0 అవుతే we know delta U is equals to NCV delta T. Change in temperature మీదనే చేంజ్ ఇన్ ఇంటర్నల్ ఎనర్జీ డిపెండ్ అయి ఉంటుంది. సో దెర్ఫోర్ డెల్టా T 0 అవుతే డెల్టా U కూడా 0 అవుతుంది. అదే ఇచ్చారు ద ఇంటర్నల్ ఎనర్జీ డస్ నాట్ చేంజ్. డెల్టా U 0 అంటే ఇంటర్నల్ ఎనర్జీ కాన్స్టెంట్ అని. సో ఇట్ డస్ నాట్ చేంజ్ ఇన్ అన్ ఐసోథర్మల్ ప్రాసెస్. సి ఈస్ కరెక్ట్. అండ్ ఫైనల్లీ డి విషయానికి వచ్చినట్లయితే నో హీట్ ఈజ్ యాడెడ్ ఆర్ రిమూవ్డ్ ఇన్ అడియాబాటిక్ ప్రాసెస్. సో యాజ్ ఐ టోల్డ్ అడియాబాటిక్ ప్రాసెస్లో డెల్టా క్యూ వాల్యూ అనేది 0. సో హీట్ అబ్జార్బ్డ్ బై ద సిస్టమ్ ఆర్ హీట్ రిజెక్టెడ్ బై ద సిస్టమ్ రెండు కూడా 0. అంటే హీట్ అనేది ఇక్కడ మనకి సిస్టమ్ నుంచి సరౌండింగ్స్కి ఎక్కడికి వెళ్ళట్లేదు. ఓకే, సో నో హీట్ ఈజ్ యాడెడ్ ఆర్ రిమూవ్డ్ ఇన్ అడియాబాటిక్ ప్రాసెస్ అనేది డి కరెక్ట్ అనమాట. సో దెర్ఫోర్ మనం ఇక్కడ చూస్తే ఏబిసిడి అన్ని కరెక్ట్ స్టూడెంట్స్. సో మన ఆన్సర్ ఏమవ్వాలి? దట్ ఆల్ ద గివెన్ స్టేట్మెంట్స్ ఆర్ కరెక్ట్ ఫర్ అన్ ఐడిयल गैस. All are correct. Option 4 is the right answer.
हेलो स्टूडेंट्स, तो आपको हमको एक प्रोसेस गिवन है, ठीक है, थर्मोडायनामिक प्रोसेस यूजिंग अ इंडिकेटर डायग्राम. ओके, ये हम ग्राफ में यहाँ गिवन है, राइट. तो देखो यहाँ पे क्या बोला गया है कि अ थर्मोडायनामिक सिस्टम इज टेकन फ्रॉम एन इनिशियल स्टेट I, ओके, विथ इंटरनल एनर्जी UI इक्वल टू 100 joules टू अ फाइनल स्टेट F, ठीक है, along two different paths IAF and IBF. Now work done by the system along the paths AF, IB and BF हमको given है, ठीक है, and the heat supplied to the system along the path IAF, IB and BF हमको given है, ठीक है, QIAF, QIB and QBF की formula respectively. If the internal energy of the system in the state B is UB and QIF, the ratio QBF upon QIB हमको निकालने का बोला गया है. तो सबसे पहले तो हमको अगर यहाँ पे इंटरनल एनर्जी हीट और वर्क डन की बात करी जा रही है तो इतने हमको क्लियर आउट हो जाता है कि हमसे सबसे पहले तो बात करी जा रही है फर्स्ट लॉ ऑफ थर्मोडायनामिक्स के बारे में, तो कि है हमारा dq इक्वल टू du प्लस dw. ओके, तो यहाँ से अगर हम पहले तो लिखेंगे AF प्रोसेस के अंदर, तो होगा QIAF इज इक्वल टू डेल्टा U ऑफ IAF प्लस वर्क डन इन IAF। ओके, दूसरा हम लिख लेते हैं QIBF हमको यहाँ गिवन है। तो पहले तो हमको यहाँ पे हमको QIAF की वैल्यू गिवन है जो कि 500 जॉल्स है, एंड WIAF की वैल्यू गिवन है जो कि 200 जॉल्स है। बिकॉज देखो IA तो एक आइसोकोरिक प्रोसेस है, तो IA के अलॉन्ग तो कुछ भी वर्क डन नहीं हुआ, ठीक है। तो IAF प्रोसेस के अलॉन्ग जितना भी वर्क डन हुआ होगा वो सिर्फ AF की वजह से हुआ होगा, राइट। तो WAF उसका, तो मतलब WIF इज इक्वल टू WAF, ठीक है। तो यहाँ पे हम इनकी वैल्यू पुट करा देते हैं। 500 इज इक्वल टू इंटरनल एनर्जी चेंज इन IAF प्लस WAF हो गया 200 के बराबर। तो यहाँ से जो इंटरनल एनर्जी चेंज इन I अलॉन्ग द प्रोसेस IAF है वो है 300 जूल्स। ओके, अब हम चलते हैं IBF प्रोसेस में। तो IBF प्रोसेस में क्या बात करी जा रही है कि QIBF इज इक्वल टू डेल्टा U ऑफ IBF, इसको जरा IBF लिखना है यहाँ पे, प्लस वर्क डन इन प्रोसेस IB प्लस वर्क डन इन प्रोसेस BF। ओके, तो यहाँ पे हमको वैल्यूज गिवन है QIBF के लिए। तो डेल्टा U IBF है मेरे पास यहाँ पे इक्वल टू 300, जो कि मेरा डेल्टा U IF के बराबर ही होगा। बिकॉज देखो जो चेंज इंटरनल एनर्जी होता है वो स्टेट डिपेंडेंट नहीं होता, ठीक है। सॉरी, वो स्टेट डिपेंडेंट होता है, मतलब वो पाथ डिपेंडेंट नहीं होता। तो चाहे मैं उसको यहाँ से यहाँ लेके जाऊँ या यहाँ से इस तरह लेके जाऊँ या फिर यहाँ से सीधा लेके जाऊँ, उस पर चेंज इन इंटरनल एनर्जी वो सेम ही रहेगा। तो डेल्टा U IBF मेरे पास भी 300 रहेगा, ठीक है। प्लस वर्क डन अलॉन्ग IB कितना है 50 है, प्लस वर्क डन अलॉन्ग BF कितना है 100। तो यहाँ से मेरे पास QIBF की वैल्यू आएगी, दैट विल बी इक्वल टू 450 जूल्स, ठीक है। अब देखो QIBF को हम ब्रेक कर लेते हैं QIB प्लस QBF में, ठीक है। जो हमको यहाँ पे रेशियोज में पूछा गया है वो बराबर है 450 जूल्स के। ओके, प्लस मुझे QIB की वैल्यू पता लग जाएगी अगर मैं यहाँ पे QIB के अलॉन्ग इसका वर्क डन मुझे पता है, बिकॉज ठीक है वो WIB है, राइट। और मेरे को जो इंटरनल एनर्जी चेंज है फॉर द प्रोसेस IB, ठीक है, उसकी वैल्यू पता है जो कि 100 है। ओके, तो यहाँ से अगर मैं सिंपली क्या करूँ कि QIB की वैल्यू निकालूँ, QIB इज इक्वल टू डेल्टा U IB प्लस WIB, ठीक है। तो इसको मैं यहाँ लिख लेता हूँ। डेल्टा U IB की वैल्यू होगी हमारे पास 100 प्लस 50 इक्वल टू 150 जूल्स, ठीक है। तो ये आया QIB की वैल्यू हम सिंपली इसमें यहाँ पुट करा देंगे। तो यहाँ से QBF की वैल्यू आएगी 450 माइनस 150 इक्वल टू 300। ओके, तो अगर मेरे को सिंपली QIB की वैल्यू पता है, QBF की वैल्यू पता है, मैं इसका रेशियो निकाल लूँगा। तो होगा QBF अपॉन QIB इक्वल टू 300 अपॉन 150 इक्वल टू 2। तो 2 मेरा सोल्यूशन है फॉर द रेशियो ऑफ QBF अपॉन QIB।